Welcome back to Grade 7 Science, Unit number 2, Matter and Materials. This is lesson number 6.2, Rate of Dissolving. If you stop and think about it, you may have noticed that different things dissolve at different amounts of time. Well, we can observe and record different amounts of time it takes for something to dissolve. The rate of dissolving is the measure of how fast a solute dissolves in a solvent. And here's a sample graph right here comparing the rate of dissolving for gold, silver, copper, palladium, platinum, and nickel. As you can see, they all dissolve at different rates. And scientists can measure the rates at which different objects dissolve and then compare the results. We can use different methods to make a solute dissolve faster. One such way is agitation. Here's an example. Let's use a mixture of sugar and water for our example. Without agitation, water particles slowly attract sugar particles away from the crystals, and it takes a long time to spread the sugar evenly throughout the solution. It reaches a point where the water particles that are close to the crystal are using their energy to hang on to sugar particles, which have already broken away, and there are no nearby water particles that have the strength to attract more sugar particles away from the crystal. With agitation, however, water particles are being moved around quickly so that there are always new water particles getting close to the sugar crystals and attracting sugar particles away from the crystals. And this is an easy one to try at home, folks. You can pour a cup of water, put some salt or sugar in the water and just leave it to sit, and you'll notice that it's going to take a long time for the crystals to mix in with the water. And then you can try it with another cup. Again, fill it with water, put in some sugar, salt, and then shake it like you're seeing on the right here. And just see which mixture is formed more quickly. The particle theory backs up this explanation. Stirring and shaking cause heat, and heat makes particles move faster. So when the solution is being stirred or shaken, the heat causes the water particles to move in, grab sugar particles, and move away so that more water particles can move in, grab sugar particles, and so on. The cleaning products which you use at home are actually powerful solvents, which have the power to dissolve nasty stains. Stains are made of particles, and household cleaners have particles that are strong enough to attract every particle in the dirt. Cleaning solvents have been tested and proven to work on cleaning stains without damaging the items they're getting the dirt out of. But we must still be careful in using them because some are powerful enough to attract the natural oils in our skin and cause skin damage. So, of course, I think you folks are at the age where you're leaving this in your parents' able hands, but when you reach that point, when you are using different household cleaning items, make sure to take note of these warning signs that tell you whether they are toxic or corrosive. And also you have to keep in mind that certain household cleaners should not be exposed to heat sources such as gas stoves or barbecue starters, for example. All right, so we're at the end of this video, but I'm leaving you with a challenge to consider, and we'll talk about this tomorrow. Now here on the screen it says, let's think of 3 times when we've seen something dissolving. I'll put it to you guys at home, each of you to think of at least one thing that you have seen dissolving. Okay, if you can think of more than one, go for it, but I want everybody to think of at least one time that you have seen something dissolving. I want you to, after you put the video on pause it, write down your answers to these questions. What did you see dissolving? Did it dissolve fast or slow? What actions, such as shaking or stirring, made it dissolve? And do you think there would be any other actions that could have made it dissolve quicker? Okay, so when I finish speaking, please put the video on pause so that you can try this challenge. If you're not ready yet, it means you go back and listen to this video at least one more time, and then when you are ready, please put the video on pause. All right, I look forward to hearing everybody's examples of times where they've seen something dissolving. But until we meet again, this concludes today's video.